Hello students, this is your paper technology second class. So to start with, first properties of cellulose. What are the desirable properties of cellulose which make it advantageous for paper making, that you have already learned in the previous class. Okay, with that here are some other properties. Number one, it is polymeric in nature and its degree of polymerization is higher. You already know its empirical formula is C6H10O5, so it is having a carbon chain. Okay, so it can polymerization, degree of polymerization is higher actually. Okay, it has the fibrous crystalline structure. It has high tensile strength, which is necessary for wave paper. It is highly inert in nature actually. It is insoluble in cold and hot water, cold diluted, acid and alkali. Okay. What are the elementary properties of cellulose? Number one, oxidation. Cellulose is highly oxidation resistant. Amount of oxidation is dependent on pH, temperature and nature of oxidant. Okay. Next is solubility. Cellulose is soluble in 72 to 75% of H2SO4 and 44% of HCl, and 85% of H3PO4 and cuprammonium hydroxide. Okay. Next is swelling. Cellulose swells in 17 to 18% of caustic soda solution. Next, what are the properties of hemicellulose? Number one, degree of polymerization is much less. Molecular weight is lesser than cellulose. In presence of hemicellulose, the time and power consumption during beating is much less. Beating is a process in stock preparation that we will be learning and in due course, okay, in the next classes. Okay, an isolation of hemicellulose from cellulose is done by caustic soda solution in presence of nitrogen. As you already know that from the wooden structure you need only the cellulose, that is the 50% cellulose in wooden structure, to be separated in order to be used in paper making actually. Okay, so next is properties of lignin. First is oxidation. Lignin is suitable for oxidation. Okay, sulfonation. Lignin is suitable for sulfonation, and due to the property of sulfonation, it is possible to separate lignin from cellulose. Okay, lignin is resistant to hydrolysis too. Okay, next is properties of extractive. It inhibits pulping. Number one actually, so it has to be separated. Okay, for paper manufacturing. Okay, uh, it is responsible for loss of absorptivity of paper with time. It is responsible for excessive foaming during pulping. Okay, so next, stepping into the steps of paper manufacturing. Okay, first raw material preparation or debarking. Next is pulping. Next is washing and screening. Next bleaching, stock preparation, approach flow system, and paper machine. So first is debarking or raw material preparation. Okay, as the name suggests, you have to debark the wood before being entered into the paper manufacturing process. Why? Because bark has little or no fiber value, number one. Number two, it contributes to dirt and it consumes the costly wood digesting chemicals. Okay, next is it lowers pulp quality. Okay, there are different type of debarker available. We will be learning here only two. Okay, a large drum type debarker. It is having a large inclined steel drum, actually cylindrical drum. Pulp wood enters from one end and forced to travel through the rotating drum and discharges from the opposite end. And the pounding and abrasive action. So this is a long steel drum. This is having a serrated inside surface. When the wood log enters from one end and travels to the other end, the pounding and abrasive action actually makes the wood bar separated from the wood log. Okay. So next is hydraulic type debarker. There are so many hydraulic type debarker. Okay, with hydraulic type debarker, high pressure, sometimes high pressure water jets are used actually, and used to separate the wood bark, or sometimes the water jet impinges on the rotating logs to peel away the bark, and these bark are used as auxiliary foils too. Okay, so here example of one, though it is not having the water jet in it. Okay, it is only one hydraulic debarker. Just take a look on it. Okay. It is just getting debarked. There is another example in the next slide. You can check it after. Okay. So after debarking, the wood can be directly sent to the pulp grinder for mechanical pulping. Okay. For other pulpings, it has to be converted into wood chips or into other suitable form for like conveying the wood to the pulping process or for the digestion process. Okay, it is done in order to permit a rapid uniform penetration of wood digesting chemicals actually into the. Okay, so after debarking, okay, if it is not going to the mechanical pulping, okay, normally multi-night disc type chipper is used to chip the or to fragment the wood logs into segments actually. Okay, the chipper consists of heavy steel disc with knives protruding from its surfaces. As the disc rotates actually at high speed, pulpwood logs are fed into the chipper with the ends directed into the path of the rotating knives, and the cutting and shearing action of the knife slice wood into chips. So take a look at it. Okay, after the chips, you get the chips, you have to screen for uniformity actually, for uniform size. And unwanted material is again fed to the chipper, or again if it is some unwanted material is there. Okay, this is the chipper knife. Okay, when the wood logs be entered from the hopper, and it will be directed to this rotating disc having protruding knife in it, it will be cutted into fragments actually. Okay, so wood logs is getting entered into it. This is this is a disc having protruding knife from its surfaces. When the wood logs enter into it, okay, it is getting fragmented, and uniform size and has to be screened, and the rest has to be eliminated actually. Okay, so this is a small block diagram of the same. Okay, the raw material debarking wood logs basically, it is fed into the chipper. Through conveyor, it goes to the chip screen where you have to segregate the uniform fragmented woods, and the reject screen outcome goes to actually it goes to the digester, like for chemical and for other pulping. For mechanical pulping, the chipping process is different. Okay. So this is a small block diagram of it. So next, after debarking, there is pulping, which is also known as cooking or digestion. Okay. So pulping is basically the fiber separation method from wood. If you remember from the previous class, wood is having 50% of cellulosic fiber, 30% of lignin, and 20% of extractives. Okay, so you have to segregate the cellulosic part actually, or fiber part, and the pulping actually accomplish this. Okay, different type of pulpings are there: mechanical pulping, chemical pulping, semi-chemical pulping. Okay, so first, mechanical pulping. Okay, the first commercial wood pulp was mechanical pulping, or it also called as ground wood pulp. Okay, in this pulping method, grinding stone is used to separate the fiber from wood. A grinding stone having different surface structure actually. Say this is a grinding stone which is rotated basically when the wood is crushed again against this rotated grinding stone, then you will be getting the mechanical pulp. Okay, and the axis of the grinding stone is perpendicular to the wood logs, which is crushed against it. Okay. So here no attempt is made to soften the lignin. Remember, there is 30% lignin in the wood structure. So there is no attempt is made to soften the lignin. Okay. Basically, the lignin is the cementing material actually between the fibers that binds the fiber together. Okay. Because the grinding itself develops enough heat to accomplish this. Okay. When the grinding operation is going on, okay, due to the friction and heat generation, some of the lignin is getting separated. Okay, as it is adhesive material, due to the heat up, okay, the lignin is somewhat getting separated. Okay, that much lignin is separated in mechanical pulping, and no other effort is given into the mechanical pulping. So most of the lignin is retained by the mechanical pulping, which is not good for the paper's health. Okay. So ground wood or mechanical pulp is mostly produced from coniferous wood. Okay. The logs are guided downward into the grinder through hoppers. And the timber is these wood logs is crushed against it by the weight of the logs above and atmospheric pressure, sometimes the pressure by a piston of the piston cylinder. Okay. And the water shower, here see, water spray, water shower wash away the pulp fiber, that is the fragmented pulp fibers away from the pulp from the grinding stone, and prevent damage of the wood from heat up and friction, and definitely to cool the environment. Okay. Wood pulp is pulp into fragments of various shapes and sizes. Now what has to be done? A vibrating screen is used. The resulting outcome of it has to be passed through a vibrating screen in order to separate the smaller pieces of pulp that falls through the holes of 5 to 6 mm diameter, and the larger pieces are rejected. A second screen accepts only 1 to 2 mm, and the rejects are crushed again by small grindstone and recirculated. Basically what it does is actually the screening process actually ensures the uniformity of pulp which you will get that goes to the paper manufacturing. Okay. So here is a small block diagram of it. The raw material storage area, that is having debarked wood. The grinding unit, okay, having the grinding stone, then the screening, okay, then cleaning, bleaching, and the next paper making operation that you will be learning afterwards. Okay. So what are the equipments used in mechanical pulping? First is hydraulic grinder, next water hydraulic magazine grinder, Great Northern grinder, Warrant chain grinder, Robert grinder, etc. There is. Okay. So hydraulic grinder. First there is hydraulic grinder. Okay. In hydraulic grinder, in this system there is a grinding stone which is 2 feet wide, and the diameter of the grinding stone is 4 feet. The width you have seen in the previous slides actually, that this you are seeing from the front. Okay. Okay. The pressure cylinder, here this pressure cylinder or the piston cylinder, the pressure cylinder is so long that the end point of the pressure cylinder from the center of the grinding stone, is 15 feet. The grinding stone rotates with the help of a motor, and the pressure of the pressure cylinder or this piston cylinder can be controlled with the help of hydraulic systems. This pressure cylinder or piston cylinders pressure can be controlled with the help of hydraulic system. That's why it is called hydraulic grinder. Here the main problem is feeding. Basically these are wood logs which is been fed through the piston cylinder. Okay, the main problem is feeding and space. Okay, the feeding problem can be somewhat solved by feeding the wood logs through the pocket in the piston cylinder, but still there is space problem. Through this pocket it can enter the wood logs, but still there is space problem. Okay. Next is, okay, so this is the grinding stone, and these are the pressure cylinder. Okay, this is grinding stone ground wood, actually. The two sides of the grinder. Two sides of the grinder. Okay. Uh, um, okay, there are two short magazines of height 2 feet. Okay, here also there is two short magazines of height 2 feet actually, and there are water troughs of 4 feet wide placed above the magazine. The wood locks of 16 feet to 60 feet are transported into these magazines manually from the storage place. The pressure of the piston can be controlled with the help of hydraulic system. Okay. So here these magazines are used. Okay. So next is Warrant chain grinder. Here the space problem is getting solved somewhat. Okay, this is the first introduced grinder where no hydraulic pressure system is used and where spacing and feeding problem are solved. There are two chains. There are two chains for two sets of wheels, and there is a grinding stone, and there is a grinding stone. The wood logs are placed inside the chain. Wood logs are placed inside the chain. The chains are moved very slowly. Okay. The speed of the chains is controlled by the governor to maintain the pressure between the wood logs and the grinding stone. Okay. So this is Warrant grinder. Okay, next is robot grinder. Okay, in this system there is a cylinder which has large number of teeth inside it. Large number of teeth inside it. There is a grinding stone inside. There is a grinding stone inside the cylinder, and a steel blade in contact with the grinding stone. The blade is used to clean the grinding stone. The wood logs are transported inside the cylinder. The wood logs is being transported inside the cylinder. Both the cylinder and grinding stone are moving in the same direction. Both these are moving in the same direction, and the pressure between the stone and the teeth of the cylinder produces pulp. Between this stone and the teeth produces the pulp. The pulp is extracted from the cylinder. Okay, so this is rubber grinder. Okay, so this is magazine, this one is hydraulic, this one is the rubber grinder. Okay, so now innovations in mechanical pulping. Okay, so first innovation is refiner mechanical pulping, or RMP. The second is thermomechanical pulping, or TMP, and third is semi-thermomechanical pulping, or Ctmp. Okay, let's explain this. Okay, first is RMP. RMP uses a disc refiner. Okay, which works by passing wood through the refiner at atmospheric pressure. Wood chips in the presence of water are introduced between the grooved surface of the two rotating discs in opposite direction at high speed, or maybe one rotating. See, here you can enter the logs with chips, which is wasted. Okay, and makes wider use of the tree species and low grade wood than the ground wood also. Okay, still it has high opacity and yield of the ground wood, because not all the lignin is getting separated, and extractives and hemicellulose are there too. Okay, TMP is produced in the same manner as RMP. TMP is thermomechanical pulping. The process is same. Okay, the disc, two opposite rotated disc, or one fixed and there is rotating disc. Okay, so what this T stands for? This is thermomechanical pulping. So here wood chips are separated into fibers in refiner operated at elevated temperature and under pressure. Okay. In some cases, chips are first preheated in the steaming vessel before passing through the refiner, and preheating soften the lignin to a higher degree. That binds the cellulose. Okay, lignin binds the cellulose, that by now you people have already known. Okay, So fibers are thereby separated more easily as the softened cheese pass through the refiner, producing more long fibers and fewer. Okay, TMP is gradually given a second stage of it's usually given a second stage of or even a third stage of treatment actually in pressurized or atmospheric discharge refiner for further defiberization and surface development of the fibers. So what are the advantages of TMP over Rmp? TMP is stronger than Rmp. It's significantly stronger than stone ground wood. Okay, it reduces and eliminates the use of more costly chemical pulps. Okay, that are blended with mechanical pulp for adequate paper strength. TMP has high yield and high opacity. Okay, newsprint made with TMP has better runnability on the press than those made with ground wood actually, because more lignin is getting separated over here, and lignin is lowers the quality of the paper. TMP is also used to manufacture coated publication paper too. Okay, now Ctmp or semi-thermomechanical pulping. Okay, TMP is there, only the C is getting added. Okay, so chemical bleaching is introduced into the TMP process. That is chemical treatment is applied to the cheese prior to the refining. Okay, the purpose of this treatment is to soften the lignin to a greater extent. Okay, than TMP definitely, because these are innovations. Okay, this produces a pulp very close in quality to wood-free pulp, that is chemical pulp. Okay, with an almost equivalent fiber length. Okay, the method is more costly than TMP definitely, because another chemical treatment is getting added. Okay, and is less general in application, because here you have to treat with the chemical, you have to treat with heat, and then you have to go to the disc refiner. Okay, as only here in the Ctmp there is there is restriction too actually. Is it uses only a higher grade of timber with a more uniform fiber. Okay, so for those kind of woods, this process can be used. Okay, advantageously definitely. Okay, the length, stiffness, and bonding properties of the fiber vary depending on the stage at which the chemical treatment is applied. Now Ctmp is not as economic as high yielding TMP okay method, but it does provide more fiber than conventional wood free or chemical pulp. The fiber produced are shorter and softer than wood free, that is chemical, and so form bulkier and more opaque paper. Definitely it will not discolor as quickly as mechanical or TMP, because some more lignin is getting separated over here, but its resistance to fading is less than wood free or chemical pulp. Definitely in chemical pulp, when you learn it, you will get the lignin separated kind of most the lignin of the lignin is getting separated, and some of the hemicellulose as well as extractive is getting separated there. Okay, so definitely in chemical pulping the quality you get is much better. Okay, it is ideal for novel and better quality books. In many cases, it is difficult to distinguish between Ctmp and the wood-free sheets. But it has a having restriction. Can be used food logs, the quality of wood logs where the fiber has more uniform fibers are there in the wood. Okay, this I have left actually. Okay. Okay, this right side, this one is the centrifugal method of cleaning. Okay, this I have left. Why I have clubbed here the picture? Actually, this is mistakenly. This is actually centrifugal method of cleaning. Here, in this process, basically, okay, screening and cleaning. Actually, in that sense, I have kept the picture over here. This is centrifugal. method of cleaning. In this process, there is a large container in which there is a blank rotating tube. Okay. The large container is connected to two tubes, as you can see. Okay, through one tube, the solution, diluted solution of fiber enters into the container. Okay, enters into the container, and through other tube, thick solution, this thick solution, which contains coarse fiber, leaves the container. In the thin solution, which contains fine fiber, comes out of the container through the rotating tube. This rotating tube. Okay, this is the centrifugal method of cleaning. So first screening and then cleaning. This is centrifugal method of cleaning. Okay, this slide should be separate. Okay, somehow I have kept it over here. So this is centrifugal method of cleaning. This one, just note it down. Okay, quality control. So I have covered. Okay. Now advantages and disadvantages. Okay. So advantages of mechanical pulping: the pulp preparation cost is much less. Okay. More amount of pulp is produced, that is pulp yield is more, because the separation of lignin, hemicellulose and extractive is too less here. So pulp yield is more. In chemical pulping, when you learn it, you will get exactly 50% pulp yield. But here you can get much more pulp yield. Paper produced by this pulp are soft and bulky. The paper have high opacity and absorptivity. It provides excellent printing cushion and ink absorbance. Though with time the absorptivity is getting decreased. Okay. So what are the disadvantages? Quality of the paper is low as lignin is present. Okay, low strength and brightness because lignin is present. Okay, the paper is subjected to oxidation due to the presence of lignin, and it becomes yellow due to oxidation of lignin. Okay, the absorptivity of the paper decreases with time. I have told you before. Okay, due to presence of extractives. Okay, objectionable sheaves or undefibered fiber bundles that are torn from the wood during the grinding. Okay. Yeah, their presence actually objection of undefibered fiber bundles. Okay. So a newsprint which is made from 75% or more mechanical pulp is a good example of paper made from mechanical pulp, and this material yellows quickly in presence of light. If you have old newspaper with you in your home, you can check that. Okay, so what are the uses of mechanical pulping? It is used extensively for manufacturing of newsprint, coated groundwood printing and publication papers, uncoated groundwood papers for magazine, telephonic directories and catalogs, household papers like towels, tissues and sanitary papers, etc. Okay, thank you. If you have any question, you can put it in the WhatsApp group.